Again, on today's show, we'll kind of explore what it takes to build a sustainable marine industry and where the biggest opportunities might exist today. So with that said, both Ollie, Alessandro, thanks for joining me on the podcast today. Great to have you.
Thanks for having us.
Thank you for having us, Jonathan.
Yeah, exciting to discuss what you all are doing. Ollie, let's start with yourself. Give us a little background on yourself with Marine Futures. You are the founder and director, and also we'll start there with your background, and then let's get into the Impact Accelerator initiative that you have going.
Yeah, cool. Thanks, Jonathan. So, yeah, in terms of my background, I'm probably about 18, 19 years now in the marine industry, working across a range of different product categories. So sailboats, powerboats, small boats, big boats. And within that, I was always kind of focused on this new product development angle. So trying to work out what's the next product that we need to develop that's going to take the market by storm. And about 7 or 8 years ago, there was a big emergence of sustainability as a topic. People were starting to ask some questions around, how sustainable are these products? What do we do with them at the end of life? And how do we build sustainable products if we did want to make a change? So that kind of spurred an idea in me to go on my own journey of discovery, if you will, when I was working for a boat builder in the UK to work out what do we do. And at the time, the general held consensus was, all of the impact actually happens in the use phase of a boat, right? It's when you're driving it, you're using petrol, diesel, you might be using sails. So we thought, okay, we need to change our propulsion systems. We need electric drivetrains. We need hybrid drivetrains. We need to investigate hydrogen and ethanol and ammonia, all these technologies. So we went off on this journey, and it was a bit of the Wild West back then. There wasn't a huge number of suppliers who were really doing marine specific kind of electric drivetrains, hybrid drivetrains. Anyway, in that journey, we came across the car industry at the time, who, in particular Volvo, who had begun to publish data on the emissions across the full life cycle of an electric vehicle versus a diesel or petrol vehicle. And the findings there were really interesting in that what you ended up with was a break-even point where at the production phase of building one of these new cars, to build the electric version was quite a higher production impact. There was more carbon emissions in the production phase because you're using battery cells, electric motors, lots of rare earth materials. And the theory was that at some point, by driving it and charging it with renewable energy or grid electricity, you would reach a break-even point where actually it is a lower impact car than the petrol or diesel equivalent. And that kind of spurred this thinking in my head of like, well, that's an interesting calculation to do for the marine industry, because we know the boats actually are used quite infrequently in lots of cases. And what I'm talking about here is in the leisure marine sector. So kind of sports boats up to say 80 feet long. And that's where we then discovered lifecycle assessment, started experimenting with it, and it told us a whole range of insights that we just hadn't considered before, to the point where actually we were possibly heading in the wrong direction with some of the choices we were making. And that was the moment where I then said, actually, probably need to dive into this and share this information with the wider industry. And that started me off on the consultancy journey of trying to share this information with the wider group. So yeah, we've been running Marine Futures for probably the last 2 years, but prior to that, we were in another consultancy business. And Marine Futures houses a project called MarineShift360, which is a joint venture, if you will, between Marine Futures and a company called 11th Hour Racing, who are a North American based ocean conservation charity. So MarineShift360 at its heart is a piece of software that allows anyone in the marine industry to log in for free and experiment and understand what the impact of the products they make is. And then the really valuable part is that once you understand kind of your baseline impact and where that impact occurs, is it your raw materials? Is it your production processes? Is it the usage of the boat? Or is it even the end of life, for instance? That's when you can start experimenting with lots of different materials, options, variables within a design system to try and find the lowest impact solution to try and create more sustainable boats. And then within MarineShift360, so it's a piece of software, but we also then run a large education program. So teaching people life cycle assessment at a fundamental level and an academic level. And then we also have what we're going to talk about today, the Impact Accelerator program, where we work directly with up to 3 companies per year who have technologies or solutions that hold the potential to decarbonize the wider industry. And that's how we've ended up working with Northern Lights Composite in Northern Italy, because they have a really, really interesting technology to look at changing how we make composites products and trying to create more circular solutions. So yeah, not the shortest version of what I'm up to, but yeah, that's kind of the potted history.
Is this software, is it AI based type software for?
There is AI elements to it, but it's not entirely. I mean, AI, some of the issue around the databases that you often use within lifecycle assessment tools, they're not open source, they're under license, so you can't just feed it into an AI tool and extract it.
Sure.
You unfortunately have to pay a bit of money to these people. We are looking at AI quite actively at the minute, though, to enhance the data collection and data entry process of creating a lifecycle assessment, to speed that up and get to the point where it gives you insights that you can act on and actually change the way you build your products.
So let's talk about the Impact Accelerator program. You highlighted that. So there's 3 companies involved. Before we get into talking with Alessandro, because he's one of the companies that you mentioned, Northern Light Composites, which you, if you would, just mention so we can give kudos to the other 2. Maybe mention all 3 and their involvement in this.
Yeah, so what's interesting this year is the 3 companies we've got kind of address different parts of the product's life cycle. So Northern Lights are obviously trying to create a recyclable solution, kind of square the circle, if you will, and have kind of this infinite supply of materials. We've also then got Gurit, who are another composites company, you know, larger scale, working across multiple industry segments, not just marine. And we're working with them to look at how do you change composite construction techniques, and also some of the raw material supply to really reduce the impact in the production phase of building a boat. And then the third company we were working with are called Mobifly. So they're a Swiss-based startup who are creating electric foiling ferries to kind of transport between, say, 10 and up to 80 people. So what they're really then addressing is the use phase of a boat. So putting foils on, you're reducing drag. Using an electric drivetrain versus a petrol drivetrain, you're reducing emissions at the point of combustion, if you will. So it's a really nice mix of companies this year, because it kind of addresses that production use and end of life conundrum that we have.
Yeah, absolutely. Well, of the 3, I would love to have all 3 of them joining, but I had the option, but I wanted to invite, definitely wanted to invite Alessandro with Northern Light Composites, because I'm very interested in what he has to say. Before we get into your technology, Alessandro, why don't you give us a little background on yourself?
Hi everyone. Yes, I'm Alessandro. I have a background in mechanical engineering. I did a PhD over the past 3 years, and I've been involved in the project of nlcomp since the beginning, since I know Fabio from the last 10 years. And but I jumped in full time the last 1.5 years now, trying to bring all my expertise as mechanical engineering to further validate and scale the technology that they have been developing since 2020.
Yeah, so I want you to highlight, if you would, the R composite. This is a thermoplastic application, and I'll let you explain to it. I've actually got some video while you're talking. I'm going to showcase that while you're discussing, so we can kind of give our listeners a little bit of a visual. So, yeah,
okay,
give us some background on this.
So, as you may already know, but most of the people doesn't know, composite materials and fiberglass specifically are very difficult to be recycled, and they are being used in many different industrial applications, from boat building to wind turbine blades to sport goods to vehicles. And it's coming up a huge problem in our days, because we don't know what to do with all the waste that fiberglass is producing once it comes at the end of its life. So this is the reason why Fabio, together with Pier Nicola and Andrea, founded nlcomp back in 2019. And they wanted to find a solution to change the paradigm of how composites are made, in order to go from like a linear economy to a circular economy. And the idea is to implement a thermoplastic resin, which allows full recyclability of each component of each composite part, together with low impact reinforcement. We make extensive use of recycled fiber, recycled core, in order to keep the environmental impact of composite material as low as possible and promote as much as possible circularity. Because we believe that this is an actual problem, and we really need to find a solution for the coming years.
So this is a thermoplastic resin. You said recyclable fibers. These are recycled. This is basically recycled fiberglass, right? Correct?
Not really. I mean,
okay.
It's maybe a small mistake with my wording. We are not actually recycling all the fiberglass, since we couldn't find a solution, and all the market couldn't find a solution.
Sure.
What we did is change what is inside fiberglass by maintaining its functionality. So we switch from a thermoset polymer to a thermoplastic polymer, and this is the key for moving into having a fully recyclable components. And also we use recycled fibers together with virgin where needed. We use a lot of recycled carbon fiber, recycled glass fiber, recycled cores, in order to promote as much as possible functionality while maintaining mechanical performances and production cycles as close as in a traditional fiberglass.
Yeah. So far, what if obviously this is relatively new in the early phases, but what types of applications on a boat are you testing? Are these small parts? I mean, are you testing this or running this on a full hull or deck, or give us some examples of applications with companies that you've worked with so far?
Yeah, sure. Since Fabio is a super ambitious entrepreneur, he wanted to go immediately all in, and we start building full boats since the beginning. Okay. We built the first prototype back in 2021. That is a 7.5 meters fully thermoplastic and flex fiber. And it also won the Italian championship back then. And since then, we kept increasing size. We built then what's called a racer, a 9-meter racing sailing boat made out of carbon, flex, and thermoplastic.
Okay.
And now we are launching our new model, which is 34 foot, so 10.5 meters offshore sailing boats. That's meant for double-ended racing, which is really which is a really important trend now. And again, this one is made out of our composite, where we put together glass fiber and balsa wood as a core, and again our thermoplastic resin to have all the hull fully recyclable at the end of its life.
What have been the biggest obstacles in implementing a thermoplastic application? I mean, Ollie and I were talking before the show. The boat industry in the U.S. This is you're not seeing a lot of this. It's still all thermoset resins that are being used. I'm curious from your standpoint in Europe. I know you guys are always moving a little further ahead than we are here in the States. But even with that, I know there are some challenges. So what have been some of the biggest challenges? And in terms of adoption, what's the feedback that you're getting from industry partners, companies in the industry? And I'll let both of you chime in from that perspective.
Yeah, from our side, the biggest challenges at the beginning was to find what are the correct process parameter in order to have at the end a composite part that has the same weight, the same mechanical performance as traditional fiberglass. Because you need to meet the same functionality while keeping the same cost and the same production time at least. And so from our side, it was an extensive research and development work in order to test different material, different configuration, different production process and production parameter that then we also protected with the patent. And we set up like a framework that allowed us to work with these relatively new materials, getting as a result a component, a part, a material, a composite material that is as good or even slightly better, even better than traditional fiberglass. While from the industrial point of view, today the main challenge that we see is to make company accepting also this slight modification in the process, because once a product is industrialized, they didn't want to change anything, and they don't want, and it's I can feel it, because you work over years in order to have it optimized.
Yeah.
But the main challenge today is to try to decrease cost and solve problem. One of the problem since cost, it's kind of difficult to address, because today fiberglass production is still mainly hand labor. So the cost of hand labor is very high compared to other industrial fields. A problem that we are trying to address is to solve an additional problem with our solution. So we are working for implementing like internal recycling of the production scrap. This is we are launching a pilot also on this in the following month, and this is a way to facilitate the adoption of a new technology to industries, because you are not only providing like a better solution from the environmental point of view, but you're also solving a problem to companies, which is waste feedstock, and which is also expensive to send to landfill.
Yeah. Ollie, any thoughts on that? Any, as I mentioned, the feedback from the marine industry there in Europe?
Yeah, I think Alessandro perfectly sums up the technical challenge that exists in this space, of which I do think there's a lot of players who are already overcoming the technical challenge and proving, with the boats these guys have built, that it works. Right. The barrier that we see a lot and spend time working on is the partnerships angle between the producer of the product and the recycling infrastructure that allows you to reclaim the raw materials that are within, our composite as an example. Sure. We've got, we need a decentralized recycling infrastructure that's at port level, for instance. Moving a 40-foot fiberglass boat across large distances is highly expensive and not that environmentally friendly. So what's been really interesting in Europe is seeing companies like Composite Recycling, based out of Switzerland, who have produced a 40-foot container unit, with a pyrolysis plant in it. Yeah. I think it's pyrolysis.
We've had them on before.
Wrong.
Yeah.
Yeah. And that's part of the barrier is bringing the recycling infrastructure to marine and port locations where the end of life product reaches its end of life. That then addresses one of the next problems, which is enough feedstock of these recycled materials, recycled fibers, recycled cores, recycled resin systems. At the minute, we're at the very kind of young stage where there probably isn't huge production volumes, which then means they're quite expensive materials to purchase, often more expensive than kind of the virgin equivalents. Sure. So there's a flywheel effect that we need to implement that enables reclamation, recovery, and then repurposing and kind of reprocessing these materials into their next life. And some of that probably does need kind of policy intervention and legislation putting in place that addresses the price balance between virgin and recycled materials to make it attractive to go for recycled. Because I think, Alessandro's highlighted, technically it's possible. We can create products that are absolutely as good, if not better. It's the price problem that we next need to address.
Sure. What's the percentage of material breaking down when you do recycle that you're able to recover, from a end of life composite in this situation for one of these thermoplastic applications?
Yeah, it depends slightly on let's say on the kind of recycling that you're willing to implement.
Hmm.
The most easy to implement is mechanical recycling, where you can actually recover 100% because you just grind down your scrap, your end of life component, and you obtain like a sort of powder that, with which you can make a compound that can be used for example, injection molding, 3D printing, and other kind of technology that make use of thermoplastic polymers. And in this way, you actually recover 100% of the composite. On the other side, with thermochemical decomposition, again, you can actually divide the different parts, so you get back the fibers and the resin.
Hmm.
And again, you can recover 100% of the fibers and roughly like 80, 75, 80% of the resin today.
Okay.
So it's a big portion.
So it's a either or. Which is more preferable, the mechanical or
The
you said that's a
thermochemical,
yeah, go ahead.
it's the more preferable because you get back the fibers as they are, so
Mhm.
you are not downgrading it, and so they are more valuable from both mechanical and economic point of view.
Mhm.
It's much easier to implement the mechanical one, of course.
Okay.
Yeah, I think the challenge is that we're always, though, looking to maintain the core material properties, so never downgrading the fiber. And,
Sure.
composite structures work because you have a continuous fiber element in them.
Mhm.
And it's when you end up with kind of your short, discontinuous fibers that you've downgraded and you've got a lower value material. So that's the holy grail, right, is to extract and reclaim all of the raw materials that went into a product
Yeah.
and then reuse them over multiple life cycles.
Yeah. And are people are they is there an overcoming of understanding that recycled materials can achieve just the same in terms of strength, durability, all of the qualities of virgin materials? Are you able to, I mean, is that something that's achievable? And is there a barrier to overcome in convincing companies or explaining to companies more or less that these materials would work in the same fashion or have be equal in durability and quality?
I mean, we always do a lot of mechanical testing every time we find a new material, new fibers, and then there is the number that works for us. So as long as you are within a very small range of variability,
Yeah.
you can say you're good enough. So and
Yeah.
also I think it's important to say, because how can I say it? Like many times we want to have like a super high performance material, carbon fiber and everything, but then you have a lot of like standards from RINA, from government and everything that impose you to put like at least that thickness, at least that much fibers, that it's almost worthless to have like super high performance material because you don't really need them.
Sure.
So I think it's also important to make this kind of clarification once we talk of alternative materials.
Yeah. Lastly, I want to direct this to you, Ollie. I mean, on average, how many? I mean, is there a number that we see in terms of like typical end of life for a boat, and how many typically on average that we're seeing that that are thermoset boats that are going to the landfill? annually, worldwide or even in Europe. I know it's a lot, right? But it's
you put me on the spot there because I don't have the fingers at my, the numbers at my fingertips. But there is, European boating industry, for instance, one of the lobbying bodies in the European space. They have published data on the volume of waste that reaches end of life, and then plotted that across a multi-year time horizon. But it's, tens of thousands of tons, I think I'm correct in saying, that's reaching end of life each year. And that's only accelerating. Because if you think of composite materials, they broadly were brought into the boat building industry in the 60s and 70s. Average boat lifespan. The good news about composites is they retain their structural properties for a long time. So they're lasting for 40, 50, 60 years.
Right.
But we're now at the point where a lot of those original boats that were built 60s, 70s, 80s, they are reaching end of life. And the volume has only increased through those decades. So it's a looming problem that we have. And at the minute, there isn't a clear policy response that is going to deal with this problem, other than lots of European countries have just banned the landfilling of composite waste and composite end-of-life boats. So where do they go? No one quite has that answer at the minute. So, and there's a clear time lag, between what's happened in the past, and we're still building the majority, almost all of the boats we're building a thermoset by their nature. So there's going to be a time lag, but the more people we can get to switch now, the lower the burden in the future for that end of life problem.
Oh, absolutely. And I think we talked about, the wind energy market before the show. It was, wind blades are a lot less. The life cycle on those are much less than boats. I think it's probably half of that, maybe 15 to 20 years on a blade.
Yeah.
So, this is something that is forward thinking on your part. Obviously it's needed. Sustainability is something in our industry that will continue to be top of mind. And I love what your industry's doing. I love what your initiative is showcasing. And so I would love to have you both, have you both back on, at the end of the year or sometime in the next year. Were you guys both at, were you at JEC this year? JEC World?
Yes. Yeah. I did attend this year.
Okay. Yeah. How was that? How was what was the feedback?
Yeah, it was really good, actually. Because we often have a bit of a marine industry focus, it's really good to go to a show like that to see what other applications and other industry segments are doing. I was very encouraged that a lot of the big players in this space are taking it seriously, even if they're not marketing it so strongly right now, because sustainability isn't quite the buzzword or topic it was 3 or 4 years ago. When you talk to them and really understand, they are developing resin solutions, fiber solutions, core solutions, even at the process level as well. To reduce plastic waste in consumables and look at bioplastics. So I'm very encouraged that the industry and the majority of the marine industry we're working with boat builders. Boat builders can't change or influence the way a large scale chemical manufacturer or fiber manufacturer is producing materials. So they are reliant on that industry shifting, but it's clear that they are. So I had a great time at JEC this year. I learned a huge amount around a lot of the carbon fiber recycling initiatives that are going on. Your Nova Carbons, your Fairmats, your Lineats. There's a huge range of amazing startups, and that's what we're looking to do where we can, is support people who have technology and are possibly in that startup or scale up phase, really break through and prove the technology out and that it stacks up.
Yeah. Very good. Ollie, Alessandro, thank you both again for joining me. Again, I would love to catch up with you maybe next year at JEC World, right? Next year, and I guess that'll be next March again. So hopefully we can catch up at the show. I was there this year, but there's only so much you can cover in 3 days. In an event like that, it's huge.
Yeah, it's a big show.
Where can people learn more about the 360 Accelerator? Is there a place that I had the website pointing earlier? Is that the best place that people can learn more
Yeah,
about this?
so we've got MarineShift360.org is the main website where we kind of publish all our case studies. We talk about our projects. The best place to follow us though is probably on LinkedIn, the MarineShift360 LinkedIn page, where we're regularly posting there on a weekly basis, kind of all the videos, news stories, and the work we're doing. So yeah, that's the best place to follow us.
Very good. We'll be sure to post a link to that on our show page, so that our listeners can check that out as well. Guys, thanks so much. I appreciate your time today.
Brilliant. Thanks, Jonathan. Good to talk.
Yep. Hang tight real quick.
Thank you, Jonathan, for having us.
Absolutely. Let's see here.